Hello everyone, and welcome to this Massive Worlds Toolkit tutorial video. In this particular video, I'll be explaining how we can use RVT Decals to further detail our landscape on top of the new Massive Worlds Toolkit landscape material. So, I made a quick demo setup for us. This is in my personal example map. I didn't want to mess with the main project. But basically it's a way for me to show you how we can use Runtime Virtual Textures to add various types of detail to our terrain, such as crater details, puddles, and then have them interact with the actual decals and the landscape material as well. And for example, road lines, right? But also how we can use it to take a mesh and make it sample from the Runtime Virtual Texture. In fact, this is just a simple mesh. If I put it near the terrain, it will start adopting the landscape material. I can move this around and it will do this pretty much everywhere. Okay, so that's pretty useful. Now the main idea here is that in this case, this particular material is used for integrating objects with the terrain, such as for example with these rocks over here, which adopt both the wetness state of the terrain and the material of the terrain and blend it in at the edges. So this is basically used to smoothly integrate these objects with the terrain. Okay, but we can also sample the RVT for our objects and then just sample it directly without this fall off blending based on distance. So how does this actually all work? Well, in the simple terms, if we have a quick look at the landscape material, no, I'm not going to go too deep, but if I look at the landscape material itself, and we look at it here, this is the main output. If I zoom out and I go over, well, let's zoom out a bit. So this material is quite complex. A lot of this here is actually quite heavy to compute real time. However, we are using a runtime virtual texture, meaning that all of this is only computed once. It's computed as a shader, and then it is stored in a virtual texture by writing it into the RVT here. So all this stuff above and over here all writes into the runtime virtual texture. It writes into the base color. We have specular, but specular in this case is used as displacement. There's roughness and there's normal. So this is one texture, these four. Then we have world height. Then we have a displacement channel, which is actually a low resolution wetness map. And then we have mask 4. Now mask 4 does mean that we can store additional information in here. Personally, I'm using this to write information from the RVT decals to the landscape material. Now the idea here is that the actual material on the landscape actually samples from the RVT again, grabs the different layers, and then uses it with some post-processing over here to modify the colors. We can add roughness, we can add the puddles, which happens in this area. So basically, we do a bit of post-processing, which is live, and then that gets output to the terrain. So between here and here, the landscape is basically stored as a texture. So the only thing this landscape material is running live is this stuff over here. Everything else is pre-computed, and the rest is related to the grass, which is a separate system altogether. So if I have a look at the landscape material itself, and I look at the, let's say the runtime virtual texture. So for that, let's go here, RVT. So here are the runtime virtual textures that the material is creating. And this is, let's say, computed live, but only when necessary is it updated, meaning that it won't be updated until it's necessary to recompute a part of this. And it can also be sampled in segments, because it's cut up into multiple pages, or let's say little subgrids, that can be loaded and unloaded on the fly. So you're not loading one giant texture, you're loading a large quantity of textures that can be loaded and unloaded on demand. Now, if we have a look at these, so here's again color, displacement, roughness, normal. Here's the world height, which basically tells the system how high the terrain is. So we can actually do stuff like this, where the mesh knows how high the terrain is without actually having to look at the terrain itself. It just looks at this height map. We have the M mask material, and then here is the wetness map. So depending on how wet our terrain is, it will store it there. Okay, so that's useful because it means that I can actually make this this object here adopt the wetness of the terrain. You see? Now, the way how we're detailing our terrain in this case is by taking additional meshes and projecting them in our terrain. This is done by using RVT Decal meshes. If we have a quick look at the roads in this map, and we find some asphalt roads somewhere, you'll find these decals, right? So these are the decals that are being placed by a Houdini tool. Then they are output to a Alembic point cloud and instantiated using PCG. This basically means that if we have a look at the Runtime Virtual Texture volume, so this one actually is the volume in our map that handles all the Runtime Virtual Textures inside of it. And if we look at its height primitive parameter, and we toggle that off, and we look underground here, you'll actually find these meshes. So these are the meshes that are being used to project into the Runtime Virtual Texture. In fact, if I hide this grid, notice how the virtual textures in this area disappear. If I unhide it, they come back. So all this really is doing is whenever this virtual texture is updated in this cell, it samples all the meshes in it that are writing to the Runtime Virtual Texture. The Runtime Virtual Texture volume will pick that up, and it will hide these meshes, assuming that height primitive is enabled. But it will still read it and write it into the Runtime Virtual Texture in the second pass. So after the landscape wrote it out, but then before it reads it back in. Meaning that we can effectively add to our landscape material additional details. You can't make it write to a higher resolution or a higher detail level, if you will, than the actual Runtime Virtual Texture is set up to project out, meaning that there is a finite resolution. So having super high resolution decals doesn't really help if you're writing it to a lower resolution terrain material. But in the end, our material is set up to a decent level of resolution, so we don't really have to worry too much about that. Now, if we go back to our island over here, and we have a closer look at this scene now that I've unhid all these meshes, check this out. We now have all these objects that are projecting into the terrain over here, right? So each of these is basically a mesh. It projects onto the Runtime Virtual Texture, and it comes with a couple of pieces of logic, meaning that if we have a closer look at its material, and we actually look at the material, not the material instance. Let's see here. Yes. So in this case, this thing is writing both into a material, which is masked, and then here it writes into Runtime Virtual Texture output. This by itself doesn't do anything, except that the moment this mesh is told to write into a Runtime Virtual Texture, such as specified over here, it will hook up with the Runtime Virtual Texture volume around the map, and it will tell it to write into the RVT. Inside this shader, there are a couple of things. For instance, we have the diffuse, normal, and in this case there's an occlusion roughness metallic channel. I also have emissive, though that won't do anything for RVT, so we can ignore that. And then here I have a dedicated displacement channel, which is, at least in our case, enabled on this particular material instance. Right there. Now this is then, in this case, remapped. If we have a quick look at the actual height map, you can actually see that there is a height map for this particular set of decals. The black areas are lower and the lighter areas are higher. The remap in this particular case is used to slightly balance it out, so I can play with the height of the decal, if you will. Now, we're currently not using tessellation or anything yet. In fact, that will take a bit more work to get right, but it is used by the puddle system. So in fact, if we have a closer look at that, and we look at these decals over here, we zoom in a bit, you might notice that there is a bunch of wetness here, but it doesn't exist on the whole decal. It basically occupies the lower part of that displacement map. So we can do some pretty fun stuff where we can create a crater in our terrain, and that can then fill up with water if we have rain or wetness in that area. Now there still may be a bit of work to do on the wetness map. Right now it's a bit of a random noise that gets scattered around the map wherever the puddles can exist. But still, it might be possible to just add that in such a way that if there's a decal somewhere and it's wet, it might just fill up with water or something. Okay, so anyway, next to that you'll notice that these lines in this case are in this area, but it's below this pothole, because that's probably what makes the most sense. But you'll also notice that we have this tiling concrete which sits below everything else, and we also have these border edges which aren't super high res, but that's not here or there. Ultimately, the idea is that these guys are being layered, and that's being handled by a setting on the mesh as well. If we look for sorting order, translucency sort priority here determines if the mesh is above or below, or rather if the texture is projected above or below. So let's say we want to make this stripe decal project on top of the border here. So we set this to 5. It'll always sit on top of it because this is the highest number. If we set it to 0, it'll probably end up below the, let's say, concrete here. So it becomes invisible. So we want to make sure that this is set to the correct height, right? To the correct sorting order. Now, in this particular case, this one's number 2, that one's number 1, and then this big slab below the terrain is number 0. So this is actually a concrete decal projected straight from a mesh, and it allows me to add an alternate texture to the terrain without having to add additional materials to the terrain. And because it's written into the RVT, you can stack these and add a bunch of detail together, and it will just work. Now also notice that I've added these decals around the edges because the transition between these guys is pretty sharp. Because this is basically just being projected straight from a mesh, right? And this is just a ray cast straight down. So in the end, this has some limitations. It will create a really razor sharp edge along the borders of this mesh. So if we want to actually integrate this properly, we'll then want to add some rim decals or something along the edges. This one allows us to draw like lines of decals, right? So we can do something like this, where we can integrate the decal with the surrounding terrain. We just gotta make sure it sits right on that edge. So if we move it a little bit to the left, like so, You can think of it as a slightly higher resolution, but still it will integrate the asphalt with these concrete slabs with this sort of edge decal. And this works with other things too. For instance, you know, we can add on top of that some crosswalks, or here in this case I have this slab which has a lower detail here with a higher ridge. So if we look at the wetness, you should be able to see that this sits on top of that. Right, there's a puddle of water here. It's still wet, but it's above the water. And then here we have this pothole which is integrated with that. So, you know, you can imagine this got destroyed. Over here we have some other concrete slab which is integrating. And the reason this works is because unlike this object here, which has a mask applied to it, this guy actually uses full-on transparency along the edges. In this particular case, the transparency is just the, well, it's the mask of this guy. But you can see how it integrates directly with the local terrain. Yeah, so in the end, if we were to, you know, then again hide our RVT, so we go back to the Runtime Virtual Texture volume, we go back to hide primitives, okay, then I can just, you know, jump in here. And I mean, I made this area pretty small, but you can see how this just works, right? Now you'll notice I do have this mesh here, and this mesh is reading from the Runtime Virtual Texture in the same way how the landscape is reading from the Runtime Virtual Texture. And it actually starts to fade out as it gets further away from the terrain. Now you can also make it so that it always reads the status of it. You can potentially make it so it blends with the Runtime Virtual Texture, like you can manipulate it or whatever. But we're basically able to grab the landscape material and the decals that we projected onto it and then apply it to a mesh above it. Okay, so we can basically make this dynamically assembled texture that's relatively light to load without having to use tons of decal projectors. And then we can layer on top of it whatever other shader that we want. So if we want to make a dedicated mesh that takes the underlying landscape material and projects it on there and then add some additional detail on there, you can do that. And that's basically it. I mean, if we want to have a closer look at how this works, it's basically the same as what I did with the trees and the rocks in our terrain. It's a material function that you can just hook into the end of an object, and here you can actually see it. Here we have some rocks, and they integrate with whatever materials underneath, where they have this transition area here. Plus, it also uses that wetness RVT layer to apply wetness to the object. So if I move this object outside of this wet zone, notice how it gets wet and loses its wetness. The only thing this doesn't do is integrate with the puddles. So if I move this guy on top of a puddle, it'll be a sharp edge, right? But outside of puddles, it's pretty smooth. That's because it both adopts the normal of the terrain and it adopts the color and the roughness, and it sort of blends between the terrain and the object. This can also be used to integrate cliff meshes with the terrain. So you can have this blend going on between them. Alright, that's it for this particular video. If you found this interesting, you can find the landscape material with the Massive Worlds Toolkit. You can find that on my website at patreon.com/erwinheims or go to eudiniacademy.com/massiveworlds. Other than that, thank you for watching this video, and I'll have more tutorials coming up. See you there.